we start with the triangle ABC. And we'll draw on the circumcircle. So the... I don't know what the fastest way to construct this in GeoGebra is. How do you spell the word triangle? We're going to introduce this median point, and why not? And I'm going to let this median point intersect... I need a name for that point. Well, we'll call it T, even though it's not really T. T is reflect. So T will be the reflection. So T is the second intersection of this ace median with ABC. And this is always really annoying to draw in GeoGebra, but I kind of have a trick. So yeah, T is that point, alright? And the so-called Humpty point is the midpoint of this segment. And enjoys a lot of properties, which I never remember because I don't use this term. And anyways, we're going to reflect D across each of the sides. So here's D. Here's E, here's F. Sorry, I meant X. Okay, and then I'm supposed to draw the 9-point circles of each of these, which is a thing that can happen, I guess. Oh god, alright. So... okay, here's one 9-point circle, and here's another 9-point circle. Oh shit, I reused X and Y. Ah! Mother. We're gonna call it Z, alright. We're just gonna use Z. Interesting. That's true? I didn't know that was true. That's the midpoint of EF, right? And this is the foot from A? Ostensibly? Okay, that's interesting. I didn't know that was true. Okay, so X and Y were like points that were defined as like it's the two intersections of the things, but they look like they're actually just like, you know. X looks like it's actually, one of the points looks like it's literally going to be the foot of the A altitude. So the first thing is like I claim that the X lies on the 9-point circle of DEF. Meanwhile, the point Y looks like it's just the midpoint of EF. And the claim is going to be that it lies on the 9-point circle too. So I was originally like trying to figure out whether this was some coaxial stuff. Is Y the foot from A to EF? Probably. Yeah, right angle. Ah, the more you know. Okay. Oh, fuck. I didn't mean to do that. So all this relies a lot on Z somehow. I wonder whether dx is also just perpendicular to line EF. Yeah, looks like it. I didn't know that was true. Wait, wow. Wow, there's just a lot of things that are true. What GeoGebra version? This is GeoGebra Classic 5, which I think is better than... I don't like 6 because it took away my input bar and I cannot function without the input bar. So in fact, I'm pretty sure like AYDX is just like a parallelogram. Wait, this is such a... Wow. That's actually a parallelogram, right? Like everything is just on everything. In fact, the... Wow, this is like blue intersect... This is the 9 point of... Okay. There's a lot going on. I need to think about this. Why does this point have so many properties? What on? Like, I actually can't tell why any of these are true. Alright, we'll take it slow. So... Oh, okay, well, okay, DZ perpendicular to BC is by definition. Like, D is actually just a reflection. But the claim is that DX is perpendicular to the pedal from Z. Which... Hang on, actually, what order do I want to do these in? Holy shit. So if Z is a Humpty point, I would, and we're doing reflections anyways, I guess what I really want to do is drop the altitudes from T, right? Because it will also give me parallelogram magic. So we're gonna call U the foot from T to line AC, and we're gonna call V the foot from okay, so V will be the foot from so like UVEF is a parallelogram, and then my question is, is this line is that line the same? I don't think it's the same angle, but yeah, it's not quite the same angle, but interesting. I don't know, man. Oh shit, sorry, I didn't... What the heck? Do I have another viewer open? How is it reading that? Huh, weird. Okay, so X and Y are actually antipodes, in fact. Like, the claim is that they're antipodes on the 9 point. Like, X is the... It's like, how do I get any control over DAF? I'm gonna hide this medium point k. I don't think I really care about it right now. If AXYZ is cyclic, it's actually an isosceles trapezoid, right? Like AY is actually equal to XZ. Everything is flipped around. Yeah, twice. Oh, fuck. I still have DA. Should have just been Z. So I know already that if X is the foot and Z is the Dumpty point and D is the reflection, I already have this XD equals YD. YD is also so weird. So the claim is just like YD is the length of the A altitude, just full stop. Which, yeah, so far all I can see is that XZ is equal to XD. I would like, I would like to at least try getting DX perpendicular to UV to start. Which is something about some angle. It's like the angle of UV and Um, I just don't know anything about Dumpty point. Like, I know it's like... Like, there's this, like, list of properties that are true for Z, and I like, don't actually know any of them, besides the fact that it's the midpoint of AC median and the conjugate of the other one, the A Humpty one. Which means something, but I don't remember what. Have you shown anything yet? Basically, no. I'm like looking at the diagram and I'm like, wow, this diagram is a miracle because like everything is just true. And that's about as far as I got. Like, you know, it's AYZX is actually going to be isosceles trapezoid. Y is in fact the midpoint of EF. X is in fact the foot of the A altitude. XY is in fact the diameter of the 9-point circle of DEF. You know, etc., etc. Like, is like everything's like a bit miracle, and then I don't know how to prove any of them. In fact, Z is the Humpty point of DAF, isn't it? I bet that's also true. Yeah. Yeah. Well, see, no, for me, usually my problem is that I can't figure out what's true. Like, I feel like it's usually like if I can see what to prove, then I just go prove it. It's not usually my problem is I don't know what to prove. Like, you know, last time we were doing the problem with the ellipse, and I just like didn't see that the point was the South Pole until I was almost done with the problem. Yeah. Okay, so Z is actually just literally the Humpty point of DEF. So this is actually a Humpty Dumpty problem, and I don't know anything about these points, so rip me. Frick. So in particular, the orthocenter of DEF actually should coincide exactly with the reflection of z across AX. Hmm. How mad will you guys be if I just complex bash the whole thing? Because that is currently my default plan, which will guarantee. The problem is if I do that, I definitely won't be able to sleep at the time I wanted to. But also, I don't. Wow, everything is just true. I can't prove anything. Because like I know how to compute z, so I know how to compute DEF, and then therefore I can show if I wanted to that the reflection of z across AX does indeed coincide with the orthocenter of DEF. Once I have that, the point x lying on this thing becomes automatic, I think. Yeah, like so x will then automatically lie in both 9-point circles. That gives you half of it. As for y, the midpoint of EF. I mean, also if you computed EF, you could just compute the midpoint directly. In fact, you wouldn't even need to factor. It was like once you have x and d, which you do, then it's like you can check that e plus f over 2 coincides with a plus d minus x. So that will give you y. It'll nail down the point y, which is both the midpoint of EF. And is it clear that if I nail that point down there, is it clear it lies on the 9-point circle of ABC? Even if it doesn't, you can check it because you know the coordinates. So that'll give you x and y, and then the isosceles trapezoid will follow automatically. Oh my god. So last week we tried a complex bash and it was a complete disaster. This looks like it is less bad, I think. I hope, like, I'm praying. It's the main thing is the point t is kind of, well, actually no, t is not bad either. Like t is the point such that the cross ratio is exactly -1. Do I dare to try to complex bash again? Do I dare to attempt another complex bash? Alright, we're gonna try it. So the first thing is I need to compute the coordinates of t. Which is given by that. So it actually is just a cross ratio, which is nice. I'm gonna just rename this to h. I don't need u and v because I'm using a complex approach. Export, asymptote, generate. And of course, z will be exactly a plus t over 2. Okay, so I think z is going to be, oh shit, what the hell happened to all these labels? Why are none of them in the places I want? Hang on. We're gonna adjust the labels for posterity's sake, okay? I'm gonna drag this a little bit so the diagram looks a little cleaner. Actually, I don't need the point of anyways. It doesn't matter. Okay, so I'm gonna postpone like actually substituting in the value of z because I don't. A lot of this calculation I think you can probably do in terms of z. And so we're gonna. So because reflections are actually really good in complex. So like the point d coincides with b plus c. Minus BCZ bar, and similarly this is E and F. So C A B C A B, and the orthocenter. Well, the point H we can actually just define as 2 times x minus d, and x is usually given explicitly by a plus b plus c minus bc over a. So if I double it and subtract d, it's like a plus bc z bar, or something really nice like this. Sorry. A plus bc over a, hang on, make it a minus bc over a minus plus bc over z bar. Alternatively, you can actually just reflect z across the chord, joining a and minus bc over a. Actually, that's probably conceptually simpler. Well, it doesn't really matter how you get it. So then it's like I need to check that E minus H is perpendicular to D minus F. So E minus H over D minus F is equal to... Alright, let's see. So the A's cancel, and it's like C minus CAZ bar plus BC over A minus BCZ bar. On the top, D minus F, you know, massive cancellation. It's like 1. Sorry, this is like C minus A. It's like 1 minus B Z bar. Okay, fine. We'll compute Z. So to compute T, I solve the thingy, and I get T minus B, A minus C. Okay, so it's like 2A minus B minus C times T minus BA minus C minus CA minus B. So T is equal to BA minus C plus CA minus B over 2A minus B minus C. And that implies Z is equal to... We are now computing the coordinates of the so-called... So it's like I add A to this and then divide everything by 2. So it's like A, 2A minus B minus C plus B A minus C plus C A minus B, and that should clean up a little bit. In fact, it's equal exactly to... so I think all the crap with A dies, and it's just like 2A minus BC over 2A minus B minus C, I think is what it is. No, that can't be right. Oh, sorry, 2A squared minus BC over 2A minus B minus C. Okay, wonderful. So this is Z if I didn't screw that up. And meanwhile, this thing, like this E minus H over D minus F, when C equals A, but it doesn't factor, never mind. Okay, guys, can you help me multiply like 8 terms? Well, okay, regardless, we actually want Z bar, because everything in here is in terms of Z bar. So, yeah, actually Z bar is more annoying than... So, 2BC minus A squared. I wonder if E and F are actually just nicer after I plug in Z bar. I can't tell from the expression, but it might be the case, because there's actually A's. Okay, I probably have to do it eventually at some point anyways. Maybe I'll just do it now. Minus, okay, so... Oh yeah, that's really clean. That actually just cancels completely. So you get like... Alright, let me get this straight. So C, 2bc... The 2bc squareds will cancel. And then you get minus ACB plus C plus 2abc minus a squared b plus c minus a squared c. No, I think I'll flip this one. Plus a squared c. Oh, so the a squared c also cancels as well. And then one of the ABCs cancels too. Wait, this is actually a little too clean. ABC minus AC squared minus A squared B. So what? It's like a I'm just too old for this. The thing is, I don't know how useful this. I really should just like plug this in and verify by hand. Because I know the denominator, right? Like the denominator is going to be something pretty good. Also, oh, okay, the numerator actually factors a little too. The numerator has a factor of c plus a, I think. Sorry, a plus, no. Yeah, it has a factor of a plus b in the sense that when a equals minus b, everything cleans. So I can write this as a plus b minus cz bar one minus bz bar. Which is good because this is going to set up the cancellation really well. Because I'll need to compute one of the two things, and then it'll give me the sort of other one automatically. So 1 minus bz bar is equal to 1 minus Okay, so we'll put this on top. And same denominator, this doesn't matter what. That denominator will eventually cancel out anyways. So it's like 2 ABC minus a squared b minus a squared c minus 2b squared c minus a squared b, or plus a squared b, which cancels out the other earlier minus a squared b. So it's like c times 2ab minus a squared minus b squared. Wait, that doesn't look right. Because that won't, if I put that in here, it's not gonna cause a miracle to happen. And I need a miracle for this to, because that numerator is too ugly. I really want this to be like, not have this 2 here. Thank you, Basudev, for the follow. Motherfuck. This should be clean. I don't know why I can't do like a 6-term calculation correctly. Like if this just didn't. Why did I mess up? No, this can't be correct because when you factor out the c, you don't get the thing you're supposed to. Like this will cancel and this thing will end up with these monomials, and when you conjugate the monomials, you don't get the same thing back. Or not monomials, the 2ab minus a squared minus 2b squared. You don't get the same thing back, I think. Or actually, no, maybe it's fine. Sorry, maybe it's okay. No, you need it to be its negative conjugate. Okay, so something's wrong. This expression can't possibly be right. So what did I screw up? E minus H. Let's see, what's PCA? Sorry, this is A plus B. But then the bottom doesn't match up, I think. Maybe it's supposed to cancel, exactly. Okay, this should be C over A though. That's awkward. So I'll factor out the C. Why are we complexing today as well? Because it's supposed to work if I could manage to do simple calculations without screwing up, which apparently is not the case. So I don't know. This is less bad than last week's calculation was pretty bad. I think this one I'm pretty confident that I will eventually finish if I don't make any mistakes. Which maybe that's a tall order. Okay, so 1 over a minus z bar is equal to like this, which is equal to, so the 2bc cancels out and I get exactly minus ab minus ac plus a squared. Okay, now it definitely doesn't cancel out, so I still have something off here. God. I'm too old for this crap. Oh my lord. What did I screw up? Okay, so when a equals b, this is supposed to equal also supposed to equal b. A equals b. Yeah. And then 2a squared minus ab minus ac minus... Oh, fuck! This is a 2. Oh god, alright. This is how I know no one's paying any attention. This is a 2. Oh god. Wait, is it a 2? Wait, I'm confused now. 2a squared minus 2ac divided by... When I set a equals b, I get a minus c here, and 2a squared minus... So it's like 2a minus c. Oh, I see. I dropped yeah. So I dropped a bunch of 2s everywhere. Okay, everything's just wrong. Everything's terrible. Okay. So a squared minus b is the correct expression. So for the expression for z, so we're just going to delete the 2bc everywhere. All right. Okay, so this thing is supposed to be, okay, there's no b there. So that means this is actually minus b squared c. And that means this here is something different. It's bc minus acb. Okay, so this one is much better. This is minus c minus c a plus b squared. C minus b plus c. And then this also factors into a product of linear factors because it's like a minus b, a minus c. Which is what we, yeah, that's much better. Okay, so that's good now because now when I take this thing and throw it in, you get mass cancellation of all the random. You get mass cancellation and you're just left with monomials, and the monomials check out. They do the thing they're supposed to do. This c cancels out this c. You get this a, you get a plus b on the bottom. This c minus a cancels out. You get a minus b on the top. So I'll resolve the entire fraction just for demonstration reasons, but I think it's going to be what it needs to be. C minus a, drop the minus signs like a minus b. C cancels, the minus cancels. Wait, is that short? Wait, it's actually just a minus b over a plus b? Seriously? Oh, I mean, okay, I'll take it. That's a right angle, but also that's a lot stronger than what I was hoping for. Wow, okay, sure, I'll take it. So hence, EH is perpendicular to EF. Usually the stream ends around midnight. I was trying to finish earlier today and failed miserably. So we're almost there. And now, like, similarly, FH perpendicular to DE. So H is indeed the orthocenter. Okay, where here we're like, let H be the reflection of Z across line AX. We compute the following complex numbers. And so H is the orthocenter. So in particular, X is the midpoint of DH exactly. It lies on the blue circle, great. And as for the point Y that we didn't deal with, well, it's the antipode of X on the 9-point circle. Okay, so like, as a consequence of the construction, like Z is the Humpty point. So, in general, if I take the orthocenter and no, wait, that's a little odd. I mean, I also have all the framework I need, so I could, in principle, just compute E plus F over 2. So E plus F of minus A plus B plus C. This will be, yeah, we'll just bludgeon it. Or I wonder if e plus f minus 2d is an easier way to see it. Like, basically, I need the d median to also be... No, actually, but that doesn't help you get it on the 9. Oh, we'll just do it this way. E plus f minus a plus b plus c is like... really good. It's like a 1 minus b z bar minus c z bar. And we already pre-computed all of these, so we can just incorporate the result. Which is like a times actually maybe I didn't pre-compute them the way I wanted them to. The I-point circle of ABC. So it's like so the 1 minus bz bar is ca plus b squared, and then I'm subtracting off another copy of c times z bar, which is going to factor, right? It better factor. So a squared plus 2ab plus b squared minus a squared minus bc, and then I factor out another b. Hang on, no, fuck. Wait, this was this thing, and then I subtracted off a copy of C times the thingy. And like this should be symmetric in B and C, so I'm like expecting some factoring that way. And I should get like, so the a squared c cancels out, and that leaves me with minus 2a minus b minus c. Yeah. So 2a plus b plus c. And then this is a minus sign. Okay, and that has indeed lies on the unit circle. So the midpoint of EF also lies on the red 9-point circle. And now we're home free. Because okay, wait, let me make sure we're done. I think this is it. Once y also lies on the 9-point circle, then dzy collinear follows from what? Wait, is it clear that dzy are collinear? Or do I have to actually compute that too? Wait, is it obvious that the... Is that clear? Maybe that's not that obvious. Okay, I'll just compute the whole parallelogram. It's fine. So d minus y, it's like d minus e plus f over 2. We eventually want this to equal a over x. And then e plus f over 2 is... we'll also do 2d minus e plus f. Okay, I think it's a little easier that way to think about. It's like b plus c minus 2a and then plus ab plus c times z bar. Wait, okay, this was supposed to... Wait, this is supposed to equal a minus x times 2, right? Wait, that's not possible. The fraction can't possibly cancel. Oh no, the fraction cancels exactly. Never mind. Everything's great. Yeah, because the fraction will give you exactly 2bc minus ab plus c. Okay, fine. 2d we're close. A b plus c minus bc over a minus a. Okay, we're good. Everything's fine. Okay, so that also establishes the parallelogram we wanted, and everything's all set. We're all done. Alright. Alright. I was trying to sleep before midnight, but I don't think it happened. Yeah, okay. Alright, I'm gonna put this into my system and then I guess we did it. Worked much better than last time. Is there a thread for this problem? On the Alps yet, or I guess it doesn't matter. It's actually pure complex. Okay, that's fine. Okay, bum. So claim H is the point H coincides with the orthocenter of the triangle DEF. So in particular, we can set x as the foot of the altitude from A, which will lie both on the 9-point circle on both 9-point circles. Claim so the midpoint y of EF also lies on the 9-point circle of ABC. Conjugate. Oh, thanks, got it. Steiner. Yeah, I don't know. So claim AX dy is a parallelogram. Where y equals okay, so in particular, a y equals xd equals xc, so that a y z x is an yeah, I'm sorry. It would have been nice to get it synthetically, but I'm too old for this stuff now. I could do a single display. It is a very nice picture. There's a lot of stuff that's happening in it, I agree. I probably want to think about this more later or something if I have the time. I'm glad you feel that way. I don't think everyone... I think a lot of people would be like, oh no, you complex matched it. I'm like, yeah, I'm just trying to solve the problem so I can go to sleep. Yeah. Okay. Yeah, because if you look at this whole calculation, like, I don't know, someone who's competent should be able to carry it out a lot faster than I did. I think the fact that I didn't realize that my Z was wrong made things really look tough on me. But in hindsight, when you let A equals B, like Z and T should also move to B. So the fact that this wasn't vanishing when A equals B should have told me that something was really wrong. This is how you always debug it beyond like homogeneous and like A equals B equals C check is like when A equals B, T and Z should move to B. So this better this better equal this thing and this thing both have to have those factors. Oh, speaking of which, this is A minus B and not A plus B. Fuck. Wait, what? No, that can't be right. Fuck. Let me fix that. In the write-up, at least. Okay, Shiba. Okay, where did I... It's the 1 minus B C bar. Okay, this thing should be a minus. Okay, which ones does that affect? I think this literally just flips the fraction. But I feel like there was another point where something weird happened. Oh, I see. So this should be a minus 2. Yeah, I overlooked that. Okay, that's fine. Yeah. Yeah, okay. Last minute catch. All right, we're done. Good job, everyone.